Hi, welcome back to another episode of Algebra in Words. What we're going to go over in today's episode is sort of an introduction to algebraic problem solving. I call it basic problem solving. Specifically, we're going to start off with the addition principle of equality and the multiplication principle of equality. They're pretty simple, but I'm going to explain deep into the details of them and how to use them and their purpose. Before we get started, I want to just remind you that if you want to follow along in written form of the topics we're going over today, you can read about them in page 42 of my book, Algebra in Words, which you can find on Amazon. The link is in the description box below. So let's get started. First of all, basic problem solving is solving basically simple algebraic problems with one variable. We get into multivariable and more complicated equations as we go. But basically, when you're doing basic problem solving, you're going to be doing possibly some form of addition or subtraction and some form of multiplication or division to get to the endpoint. What is the endpoint? The endpoint means taking an equation and isolating x. So it's x only on one side equal to one number on the other side. And there's different variations of that depending on whether you're doing equations or formulas. We'll go over that later. But for now, let's talk about the addition principle of equality. I have a couple example problems on the board that we're going to work into the definition. What does the addition principle of equality mean? It's simple. There's kind of two parts to it. One part is whatever you add to one side of the equation, you must add to the other side of the equation. That's to maintain the equality of the equation. Secondly, what's the use, what's the purpose or the function of the addition principle of equality? Well, let's look at this first equation. X minus 3 is equal to 14. Remember, the goal is to isolate x, to get x on one side by itself. That'll be the end of the problem. But on the left, next to the x, we have minus 3. Okay? So the question is, how do we move the negative 3 to the other side? Oftentimes you hear teachers say, move it to the other side. That's kind of shorthand for the specific of using the addition principle of equality. All right, so how do we move it? Well, think about this. We want negative 3 to become 0. Think about this. What do you have to add to negative 3 to make it 0? Well, you have to add its opposite of itself. Opposite means the opposite sign. So if this is negative 3, adding 3 to negative 3 would make 0. So we're going to do that on the left. And remember that what you do to the left, you have to do to the right to maintain the equality. So negative 3 plus 3. This cancels out the negative 3 to 0 on the left. So I'm just going to write x because you only have x now on the left. And on the right, add 14 plus 3, and that's 17. So the answer to that would be 17. A fairly simple problem, but again, it's to exemplify the basic principles behind that. Okay? Let's look at the other problem I have up for this. X plus 11 is equal to 15. Okay, now I like to analyze the problems. Let's compare the problem on the left and right so you know the purpose of why I chose them. In the problem on the left, we have x minus a number. The problem here, we have x plus a number. Okay, I chose a minus and a plus so that we got to look at each type. Again, what I want you to think of is we want to isolate the x. How do we do that? Well, it's to move the 11 to the other side. How do we do that? What do you have to add to 11 to make it become 0? Its opposite, which is negative 11. So I'm going to subtract 11 from both sides. And let me pause there because you might be saying, well, if this is the addition principle, why are we subtracting? Well, remember, sort of as I discussed in the order of operations episode, you have to remember that adding can also be subtracting if you think about it as adding a negative number. Okay, so that's what we're doing. We're adding a negative to both sides. But if you know it as subtraction, that's honestly good enough. So we're subtracting, in this case, 11 from both sides to eliminate or cancel out this 11. So on the left, that gives us, once again, x. And on the right, when we add 15 minus 11, we get positive 4 or 4. And that's it. So those are two examples of using the addition principle of equality to simplify a very basic problem involving plus or minus. Okay, so then that brings us to the multiplication principle. Let's start with this simple equation here, which is 1/7 x is equal to 6. Okay, now remember, again, to reiterate, the final goal is to get x alone. Okay, we want to have x isolated. Another way to think of it is 1x, right? But we don't write the coefficient 1x for 1 in front of the x. It's just x. Right now, there's no pluses or minuses, but there is a coefficient, 1/7 in front of x. It does happen to be a fraction, all right? And before we solve, this is the way that I think you should think about canceling out the coefficient in front of x from here on out, okay? You should think of it as multiplying. What are you multiplying? Think of multiplying both sides times the reciprocal of the coefficient in front of x. What's reciprocal mean? It's the upside down of the fraction, okay? So if this is 1/7, what's the reciprocal of 1/7? It's 7 over 1, or you could just say 7 because you don't have to write over 1. Looking ahead at this problem where we have 7x, with no denominator unless you say it's over 1, but we don't write the 1, what's the reciprocal of 7 over 1? It's 1/7, all right? So we'll come back to this problem. Let's solve this problem first. And as we just discussed, multiply both sides by the reciprocal of 1/7, which is 7 over 1. And I'm going to write the 7 over 1, even though we don't have to write the 1. All right? Now we can implement some basic canceling out of common factors. 7 over 7 cancels out to 1. We have 1 over 1, which you could just say 1. You don't have to write the coefficient 1. We get x on the left. And on the right, we have 6 over an unwritten 1 times 7 over 1. Multiply the numerators. What's 6 times 7? 42. All right, we'll go on to the next problem. Notice that I have the same problem here, essentially, as we had on the left. I'm going to come to that one in a second, because there's a reason why I put that up again. But let's go to this one, where we have 56 is equal to 7 over 7x. All right, and again, when you have a coefficient that you need to move or eliminate in front of x, multiply both sides by the reciprocal of the coefficient. If the coefficient is 7, the reciprocal of 7 is 1 over 7. So we're going to multiply both sides by 1 over 7. On the right, the 7's cancel out to 1, leaving x. On the right, we have 56 over 7. 7 goes into 7 once, and 7 goes into 58 8 times. All right, and below I'm just going to write 8. 8 equals x. This is a suitable answer. You could also reverse it and say x equals 8, as we usually put the x on the left. But if you have 8 equals x, I think that's good enough for now. One other little detail is, notice that on this problem, the x is on the right. And that's okay. You'll sometimes find the x on the right, sometimes on the left. Okay, so I'm going to pause this video and put up another problem or two where we're going to analyze a simple problem where the addition property and multiplication property are mixed. Okay, so before we do an actual problem solving, I put up a basic, 4 basic steps that we want to use for basic problem solving, okay? And if you follow these steps, especially if this is very new to you and it can be confusing, If you follow these steps, hopefully it'll make it very clear as to what to do and in what exact chronological order. The first step that I have here is to eliminate denominators. And the second step that I have here is simplify as much as possible. Okay? I'm going to talk about both of these steps sort of combined for a second. Steps 1 and 2, generally speaking, is you want to simplify as much as possible and prepare the problem for steps 3 and ultimately 4. Okay? The problems that you'll encounter will come in various different forms, obviously. The reason why I have eliminate denominators as the first step is because sometimes the problem can come with fractions. It might be one fraction, it might be multiple fractions. It doesn't matter how many fractions, and I go over how to eliminate fractions and use least common denominator in later videos. You can specifically look for them in rational equations, but I'm going to try to do problems that use fractions throughout this series in all situations. So anyway, if you encounter a problem with fractions, it's a good idea as the first step to eliminate all fractions by eliminating all denominators. That would mean multiplying each term throughout the equation by the least common denominator. Okay? In another video, I go over finding least common denominator and greatest common factor. What about step 2? It's sort of a general step, but it's important. Simplify as much as possible. What are some examples of simplifying as much as possible? One of them sort of is to get rid of the fractions and denominators if possible. I just discussed that. Another one is if the terms come in, if there's multiple terms that are alike on the left and right or even on the same side, you want to combine like terms as much as possible before you move on. Okay? Also, if there's groups, you want to simplify in the groups, and it might require a distribution to get to the next steps. I would count even that as a simplification step as well. And I think that basically covers it. Remember when you're, whatever type of situation that you have, remember to follow order of operations. Now, I brought up order of operations for a purpose because if you remember order of operations, we do the multiplication or division steps first before we do addition or subtraction steps. That's by order of operation. Okay, but I want to point something out here so that you don't mix these up. Notice my step 3 is add or subtract, and my last step is multiply or divide. Okay, this step is what I refer to as the addition property of equality, and the last one is the multiplication property. But again, how do these relate or contrast with order of operations? Well, this is the third step, and it's very important to focus in on the key elements and key words of this. The third step is add or subtract to isolate the term with the variable. Okay? I'll put up a problem where we can see the term with the variable shortly. And the fourth step and last step always is going to be to multiply or divide to isolate the variable. Okay, notice the difference. This is to isolate the term with the variable. This is to isolate the variable. And also, before I put a problem up, notice that we're generally going to do the addition step before the multiplication step. Okay, that's kind of independent of order of operations. Order of operations is for simplifying. That could be within a group. It could also be for an expression. But when we're solving an equation, it's not that the order of operations are different, but remember, the order of operations are for simplification. We would do that more in these steps, okay? But for solving, we're always going to do addition or subtraction to isolate the term with the variable first, and finally last, use multiplication or division to isolate the variable itself. Okay, so I put a problem up on the board with mixed properties, mixed principles. 3x plus 5 equals 11, okay? So let's go through the steps. I had to erase them for boardroom, but let's go through the steps. Are there any fractions with denominators? No, so we don't need to do that. Is there anything else that we can simplify as much as possible before we go on? No, there's no terms to combine, and that's pretty much it. You could argue in the next step that there is, and that's what we're going to do next. So if you remember the third step, I say, isolate the term with the variable. what's the term with the variable? This is the term with the variable, the term 3x. We want to get that alone before we do the last and final step. To do that, we're going to subtract 5 from both sides, which is going to give us 3x is equal to 6. Okay, pretty simple. And that brings us to the last step. Okay, if you remember, in the last step we said to multiply both sides by the reciprocal of the coefficient in front of x. Okay, if you think of 3 as 3 over 1, what's the reciprocal? It's 1/3. Okay. You could multiply both sides by 1/3. That's a good rule of thumb when you're starting out. But ultimately, when you get comfortable with it and you just kind of do it the way most people do, if you can divide, you're going to divide. Okay? If you divide 3 by 3, because any number over itself is 1, then these coefficients of 3 cancel. Remember what you do to the left, do to the right to keep the equality. So we'll divide the right by 3 as well. And we get x equals 2. Okay? Pretty simple, I understand that. But again, it's to reiterate and reinforce the basics. We isolated the term with the variable first, using addition subtraction. That brings us to here, and then we finished off with multiplication or division. It's kind of the same thing. We use division to isolate the variable, x equals 2. So I'm going to pause this and put up another slightly more complicated problem. Okay, so I have another problem on the board, and it's a little more complicated than the last one. In this case, notice that we have a group. When we have a group, I've always been taught to call it a quantity. You may hear me call it a quantity from here on out. 2 times the quantity x minus 4 is equal to 5x minus 14. Okay, so are there fractions? No. But is there anything to simplify? Yes, because we have a group and we want to distribute the 2 through the group because that will make 2 new terms. So 2 times x is 2x. 2 minus 4 is negative 8. And I rewrote the terms on the right. Okay. But now we still, our short-term goal is to isolate the term with the variable. But we still can sort of simplify, all right? It's kind of a hybrid of step 2 and 3. Are there any terms that we can combine? Well, these are both like terms, and these are both like terms. So one question I sometimes get is, does it matter if you move the terms with x to the left or right? It doesn't matter, but I think just for consistency, it's a good rule of thumb to move the terms with x to the left. So let's just do that just to be consistent, and then the numbers to the right. We can do it in separate steps, but I think we at this point can do them in one step. Here's what I mean. So we have 5x on the right, we want to move it to the left. We're going to subtract 5x from both sides. You might like to line these up just to make it more orderly to follow along. All right, but also we want to move the 8 or the negative 8 to the right, so we're going to add 8 to both sides. And just to pause and reiterate what we're doing and why, we're moving the term with the variable to the left by subtracting 5x from both sides, and we're moving the constant, the number, negative 8, by adding 8 to the right by adding 8 to both sides. All right, so let's just do the math and then see what we come up with so far. So this is going to give us negative 3x equals, these cancel to 0, equals, and then we have negative 14 plus 8 is negative 6. All right? Notice we isolated the term with the variable. Okay? That's negative 3x so far. And we also combined all like terms. The constants became negative 6, which is now on the right. So we've simplified everything as much as possible. We used addition or subtraction and the addition principle to isolate the term with the variable, which we see here. And the last step is, how do we get rid of the coefficient negative 3? Divide negative 3 to both sides, which will cancel out the negative 3's to 1, leaving x. Negative 6 over negative 3 is 2. Okay, I think this will be the last problem for this video, but I put another problem on the board strategically. Notice that there are fractions. We have x over 6 plus 1/3 is equal to x over 2 plus 5/3. Okay, so before we rush into the problem, let's again pause and let's analyze this, and I want to just go over a few little nuanced key points. Okay, because this might be a little new to you, maybe not, but I still want to address these points. First of all, here's what we are going to do. Now clearly there are fractions, there are denominators. What we're ultimately going to do is multiply each term through by the least common denominator, which we'll figure out in a second, to get rid of all terms, all denominators, which will get rid of all fractions. But before we do that, let's address a couple possible questions. One question is, okay, you might be compelled to add or subtract fractions. Okay, so for example, this term has x, this term has x. They are like terms. They have the same variable and the same exponent, x to the unwritten 1. And so you might say to yourself, especially coming off of maybe previous math classes, should you add x over 6 with negative x over 2, if you subtracted x over 2 from both sides? Should you combine fractions? And the answer is you could, but really the best answer is no. Why is the answer no? Because ultimately, okay, adding and subtracting fractions, not that it's frowned upon, it's a skill that you're going to have to be comfortable with, but ultimately it's just going to be sort of too much work for really no reason. All right, there's faster, easier, more efficient ways to get to the end of the problem, and if you can do it, you should do it. So we're going to avoid adding and subtracting fractions. And again, it's just sort of unnecessary, although you could. Secondly, just in case, what if you're compelled to convert the fractions to decimals? Is that wrong? It's again not wrong, but it's not preferred. Why is it not preferred? Well, if we're talking in terms of rational and irrational numbers, sometimes numbers are in their best form, their most accurate form as a fraction instead of a decimal. So could we convert them into fractions, into decimals, and then combine like terms and solve for x? We could, but again, it's best to just get rid of the fractions. All right, so let's do that. If you remember my four-step procedure for solving basic algebra problems is if there's fractions, get rid of them. All right, we have denominators 6, 3, 2, and 3. Okay, as I said, I go over least common denominator in another video, but for now, I'm just going to tell you that the LCD is 6. I'm just going to write that on the side, just so that we have it there, okay? Because I encourage you to write the LCD from here on out whenever you have one. It's just better to write the steps out. All right, so we're going to multiply each term by the LCD 6. And I'm just going to do that by writing it in parentheses like that, okay? And let's just cancel out any common factors that we can. Remember, in this step, if you do it right by finding and using and multiplying by the least common denominator, it will and should eliminate all denominators so that there are no fractions left by the next step. 6 over 6 cancels out to 1, leaving x. Okay, 3 goes into 3 once and into 6 twice. 2 goes into 2 once and into 6 3 times. And 3 goes into 3 once and into 6 twice. So I just wrote, canceled out the common factors and wrote any leftover factors above. All right, so let's start back on the left. Leave out what we canceled out and then rewrite what's left and multiply wherever we need to. So these canceled out, we have x. Then we have 1 times 2, keep the plus. All right, and we don't have to write over 1 because we just don't have to do that. Then we have x times 3, we could call it 3x. And then we have 5 times 2, which is 10. now we're at the point sort of that we were at in the last example problem. There's 4 terms. Remember, we want to isolate the term with the variable and simplify as much as possible, which would mean combining like terms if possible. Alright? So if our goal is to move the x terms to the left, let's subtract 3x from both sides, and we can line them up. And if we want to move the 2 to the right, we can subtract 2 from both sides. Alright, let's go back on the left and do the arithmetic. 1x minus 3x is negative 2x. 2 plus minus 2 is 0, cancels out to 0, so we don't write anything for that. 3x minus 3x cancels out to 0, so that's eliminated. And 10 minus 2 is 8. Okay? The term with the variable has been isolated. Next step, we want to isolate just the variable. That's using multiplication or division. We have a coefficient of negative 2, so we can divide both sides by negative 2. Negative 2 cancels negative 2, leaving x. 8 divided by negative 2 is negative 4. And that pretty much concludes this video on basic solving of algebra problems. Okay, the problems will get more complicated as they go, and of course we'll address them and all the various aspects in future videos. So anyway, thanks for watching. If you found this video helpful, please give a like, please share with your friends, please subscribe to the channel, and I'll see you next time.